So welcome to our first roundup video on natural hazards. In this video, we're going to be looking at the definition of a natural hazard. We're going to be exploring some of the factors that can affect people's vulnerability to hazards. And we're also going to think about how people's attitudes towards risk varies and how that can lead to people developing different perceptions of the severity of risk posed by different hazards. It's important that we start by thinking about what we actually mean by a natural hazard. So I quite like to use this diagram when we're thinking about what we mean by a hazard. We can think about perhaps a geophysical event, something like an earthquake or a tropical storm or a volcanic eruption. Those things can happen perfectly naturally, but they only become a hazard when those events overlap with and come into contact with a vulnerable population. If, for example, an earthquake, small magnitude earthquake, happens out in the middle of the ocean where there are no people, we can just think about that as being an event. That is not a hazard. It's only a hazard if that earthquake was to happen close to a vulnerable population. So where those two things overlap, the event and the vulnerable population, the hazard lies within this little boundary in the middle. You have to have that overlap with a vulnerable population in order for people and property to be at risk. Now, there are many different types of natural hazards, and we can group them broadly into these three categories. So we can think about there being geological hazards. Those are hazards caused by Earth's processes. Things like earthquakes, volcanic eruptions, or landslides would fit into that category. We can think about there being atmospheric hazards, hazards created by changes within our atmosphere and associated with our weather. Things like tropical storms and tornadoes, even wildfires. And we can also think about there being hydrological hazards, hazards associated with water, things like flooding, for example. Now, some hazards can fit into more than one category. For example, a tropical storm, which is an atmospheric hazard, that can create lots of rainfall. That rainfall can actually then trigger landslides, which would be a geological hazard. Atmospheric hazards like tropical storms can also create flooding, which we would see as a hydrological hazard. So there isn't always a perfect line between each of these categories. There is some blurring of the boundaries between them. But broadly speaking, we can think about hazards fitting into one of these three categories. Now, a really important thing to understand about hazards, and we're going to come to look at this on all of the different types of natural hazards that we come to look at, is the idea of magnitude. Whenever we're thinking about a hazard, we want to appreciate the magnitude of that hazard. And by magnitude, we are basically referring to the size and the scale of that hazard. Now, that varies between maybe earthquakes or tropical storms and volcanic eruptions in terms of how we actually measure the size of it. But in all cases, the magnitude is referring to the size and the power and the impact of that event. We also need to consider alongside that, though, the frequency of the hazard. So how often that hazard is occurring. So if we have a look at this graph that we've got here, down one side, we've got the magnitude of earthquakes measured on something like the Richter scale here. So we've got a magnitude 2, 3, 4, 5, up to 10. Along the bottom, we can think about this scale as being the number of earthquakes that we get around the world each year. Now, there's no scale on this because varies from year to year. We've got some numbers up the middle there to give us a rough idea about how those frequencies change. So as you can see, down the bottom of that magnitude scale, when we're looking at things like magnitude 3 or magnitude 2 earthquakes, they're relatively small. They're only just about detectable by people. We have in the region of hundreds of thousands to millions of those earthquakes happening per year all around the world. They are very, very frequent, but because they are so small, they don't really have much of an impact. At the other end of the scale, though, things like magnitude 8 or magnitude 9 earthquakes, they are very, very large, but only happen very rarely. We may not even get one of those earthquakes happening in any given year. So this applies to all hazards, not just earthquakes. We would expect that larger magnitude events occur less often and smaller magnitude events occur more often. And that's relatively easy to understand when you think about maybe the things causing those events. So earthquakes, for example, are the release of energy that's stored within the Earth's crust. Now, in order to build up enough energy to create, let's say, a magnitude 9 earthquake like the one that happened in Japan in 2011, the amount of energy needed to create that size earthquake is absolutely huge, and it takes hundreds and hundreds of years for the energy to build up to that level in order to be released. On the other hand, the amount of energy needed to create a magnitude 3 earthquake, for example, is incredibly small. Okay, you can get a sense of the amount of energy released here when we think about this scale here. So the energy needed to release a magnitude 9 earthquake, 1.8 trillion kilograms of explosive would be needed in order to generate the same amount of energy. Down here, though, for a magnitude 3, you'd only need 1,800 kilograms. So that's a huge difference between those two magnitudes. What that tells us is that we are likely to experience those big magnitude events less frequently, but the small ones more frequently. We can think about it looking like this on a curve, for example. So if we had frequency at one side, magnitude along the other axis, we'd expect small events to occur more often, larger events to occur less often, but actually it's these events in the middle, these kind of medium magnitude events with a medium frequency, they're the things that actually often do the most work overall, because they're kind of ticking both boxes in terms of being large enough to have some influence and occurring often enough to make that influence really, really add up over time. So we will come back to look at the specific kind of magnitudes and frequencies of hazards, but this is a really important concept to hold in your mind in this topic, that big events occur less often than small ones. Now we can start to also think about why some people are more vulnerable when it comes to hazards than others. The level of risk that people face around the world is not equal, and that is evident when we find these hazard events occurring in less developed parts of the world. We see that their impact is significantly larger than maybe a similar sized event happening in a more developed part of the world. So we can have all of these different hazards occurring: winds, floods, droughts, landslides, tsunami. We can think about those being the hazard event. And as I said earlier, it's got to come into contact with this vulnerable population. Now, different things can make different populations more or less vulnerable to the impacts of a hazard. The absolute two most important ones are these two here. Poverty. If people don't have access to the basic resources that they need to survive, they are going to be impacted much more severely by a natural hazard. So poverty is up there as being one of the leading causes of vulnerability. If you are poor, you are much more vulnerable to a natural hazard in a whole number of ways, and we're going to look at those in a second. The other thing that makes populations fatally vulnerable is the idea of poor governance. So where the political, social and economic systems within a country are not up to standard, where the laws aren't strong enough to ensure that buildings are built properly, where governments are corrupt, those political systems let people down time and time again. One of the examples that we'll look at as part of our work on this topic is the example of the earthquake in Haiti in 2010. A long time ago now, 10 years ago, but it is a great example of where poverty and poor governance combined to absolutely decimate that country. So these factors, poverty and poor governance, they kind of feed into these kind of pressures here. And they can be on a number of scales. There could be things that are happening on a local scale. So people might not be particularly well educated, educated in terms of the risks of hazards. They might not be trained in what to do if a hazard occurs. There could also be food security issues. People could be experiencing shortages of food before a hazard even hits. Therefore, after the hazard, they're going to find it even harder to try and meet those basic daily needs. Other things can have an influence as well. So maybe the rate of population change or the rate of urbanization, that can cause large numbers of people to end up living in low quality housing. It can put pressure on food supplies. It can put pressure on the economy. Countries perhaps could have issues repaying debt to other countries. So low-income countries in particular, where they've maybe borrowed money from other countries in the past, servicing that debt takes up a lot of their income, and they don't have that extra money available to actually spend on things that might protect them in the event of an earthquake or a tropical storm. There's also the possibility that maybe locally resources have been overexploited, or there's been extensive deforestation. That would be a real problem in areas that are vulnerable to landslides or to tropical storms, because the trees naturally would intercept a lot of rainfall. They'd hold the soil together. If the trees aren't there because they've been deforested at an unsustainable rate, then they are going to be lacking and not holding the soil together. They're not going to be intercepting the rainfall. That's going to make the impact of the hazard a lot worse. There can also then be conditions within the population that make things unsafe. So people could have built houses in dangerous locations. This maybe links with urbanization here. If people are moving into a city very, very quickly because there's rapid urbanization, they're building houses on land that might not be that safe, might be prone to quite violent shaking in an earthquake. Buildings might be left unprotected if the government doesn't have the money to help pay for grants for people to actually build their homes properly. They might be left unprotected if the government doesn't have the systems in place, the laws in place to actually enforce people to build their houses properly. There can be socioeconomic factors as well. So a poor quality economy is going to lead to poverty. That can mean that people are going to be unprepared for disasters. They may be not able to stockpile food and resources that might see them through that critical week or two after the hazard has struck. The facilities such as sanitation might not be as well developed. That might mean that disease is going to spread more easily following a natural hazard. So there are lots and lots of factors that come into play to make a population vulnerable, but really, when you unpick all of these things down here, they're influenced by these two: poverty and poor governance. That is what makes populations fatally vulnerable to all sorts of natural hazards. Now, we should also think, though, about people's individual attitudes to risk. So I've just put up here 6 different pictures of 6 different activities that some people might argue are quite risky, and other people might argue carry very little risk at all. Some of those risks are quite well documented. So smoking, for example, we know that comes with very, very well documented health risks, but some people still smoke. Things like e-cigarettes, vaping. Many people would argue that that's less risky than smoking, but actually the statistics surrounding that have been less well tested. So maybe we don't know as much about that as we do about certain other things. Riding a horse, for example. Some people might do that quite regularly and think that's perfectly safe and perfectly natural. People like me, on the other hand, who've only ever ridden a horse once in their life and were absolutely terrified by that experience, we might approach the same activity with a very, very different viewpoint. So it's important to understand that actually the same thing, the same activity, or in this case, the same natural hazard, can actually be viewed as more or less risky by one person than another. So something that we might think as being quite concrete and quite fixed, like riding a horse, actually, if we were to survey everybody in the class or everybody in the school, people might rate that level of risk quite differently. And that poses a problem when we come to think about natural hazards. So people's attitudes to risk are influenced by a number of different factors, and very often it's a combination of lots of things. So one of those might be your socioeconomic status. So the amount of money you have could influence how risky you perceive a certain natural hazard to be. If you have nothing to lose, you might feel like you're willing to take more of a risk. If you are quite well off and are perhaps able to afford insurance for your property and your belongings, then actually, again, maybe you might see something as being less risky because actually you know you're going to be perhaps supported financially should a hazard occur. People's levels of education is important. If people are aware of the levels of risk and are aware of the things that they can do to protect themselves, they may be more likely to actually do that. It's when people are perhaps uneducated about the level of risk that they perhaps over or underestimate things and then get themselves into trouble. Even people's occupation or employment status can play a role. So if you are a poor farmer with very few possessions, living on the slopes of a volcano, then actually you might be more inclined to stay put if that volcano shows signs of eruption, because actually everything you own is there on the side of that volcano. You might be willing to stay and protect your livestock or your property or your crops to whatever extent you feel necessary. People's religion and cultural backgrounds are important. If you see something as being an act of God and something that you can't do anything about, then maybe you're less likely to take action to protect yourself because you might see something as inevitable. Family and marital status are important. It's well documented that single young men take more risks than perhaps married women do. That's why young men aged 17, 18, that's why their car insurance prices are much, much higher, because they are seen as being risk takers, whereas maybe people who are married or have children might feel a sense to kind of protect those people and therefore might be willing to take less of a risk when it comes to natural hazards. Past experience can play a factor. So if you have lived in an area for a considerable amount of time and maybe you've survived lots of tropical storms in the past, you might be more confident about surviving them in the future, and therefore you might be willing to take more of a risk. Kind of links back to what I was saying a moment ago about the influence of people's experiences, maybe like riding a horse. So if you ride a horse all the time, you are less likely to see that as being a risk. On the other hand, maybe if you have experienced a traumatic event associated with a tropical storm or an earthquake, then actually you might remember that next time, and that might influence how risky you see a future hazard to be. So there are lots and lots of factors, including, it says here, people's values and their personality and their expectation. All of these kind of things can influence how risky people see a particular hazard as being. That can then go on to obviously influence whether they are more or less likely to evacuate if they're told to, how much effort they go to protect themselves or their property when that hazard does actually realise itself. This then leads on to people basically having one of three viewpoints associated with natural hazards. So all of those factors influence people's perceptions, and they basically fit into then one of these three categories. So they might take what we call a fatalist viewpoint, sometimes called acceptance. So this would apply when people perhaps see natural hazards as being an inevitable part of life. They're like an act of God, and therefore when they do happen, people are just concerned with kind of protecting themselves there and then in the moment. They don't really plan for them. They're not really getting prepared for them. They're just living their lives normally until they happen, and then kind of reacting to it when they do. Second viewpoint is the idea of adaptation. So this is where people realize that they live somewhere hazardous, like California is exposed to earthquakes and wildfires, or somewhere like Japan, and they realize that actually these events are hazardous, but through a mixture of prediction and protection and prevention, we can do things that will help to lessen the impact of those hazards. So they're going to continue to live in that hazardous environment because they see that on balance, actually, they can do things that are going to help to protect them in the future. The final viewpoint is what we would call one of fear. So this is where people see that a hazard poses so much of a risk and they feel so vulnerable that they basically are no longer able to feel like they can live in that area. They therefore move away and don't come back to that area because they feel like there is too much of a risk. So ultimately, people would fit into one of these three categories depending on the way that they saw the risk posed by any particular hazard.